All right, now, what I'd like to do is to talk about some special G codes that come into play when you are working with offsets on the machine. This is what's really happening. We have this notion of work coordinate offsets. And this is a very important concept because what you've seen up till now is the examples we've used have been coordinate origins that exist on convenient locations related to a component that we're machining. So if we're machining a square, that's 2 inches by 4 inches, has some kind of hole in the middle, you already know how to do all this. You say, okay, I'm going to pick this corner as my datum, and I'm going to call that x0 and y0, and now everything I do relates to this datum point. But what you need to be aware of is that you will continue to program thinking like this, but what's really happening is you have a machine table that this part is located on. You might be holding this with a vise. So here's our vise. And you must realize that the machine itself has a datum point. As far as the machine is concerned, this is x0 and y0. Not your point. What we need to do is we need to tell the machine that, hey, for my part program, you got to know that your datum and my datum are not the same thing. That my datum exists as a locational offset. I'm going to call this x offset. And I'm going to call this y offset. We need to tell the machine that our zero, our datum, is a certain distance away in x, and it's a certain distance away in y. Otherwise, if we didn't inform the machine where this is, what these values are, and you tell the machine go to x0, y0, it's actually going to move your cutting tool right there. And then if you go and you say, make a move to y2, so if we said g00, x0, y0, and then we tell the machine g01, make a move to y 2.0, it's going to go from this point and go 2.0 inches up, and it's going to actually try to machine your part up here, because you have not told it that your actual datum is shifted a given amount away from the machine datum. So two things happen. Your operator, or you who are setting up the machine, will indicate this corner. If this is the hard jaw of the vise, you will indicate this edge and that edge, and you will get a number, which we demonstrate to you, out on the floor, on the control. It will tell you, once you've indicated this, and you saw us do that with the vise, But you're going to indicate this edge and you're going to locate where this corner point is in relation to what we call the machine coordinate system. So the operator and setup person are going to indicate that and key into the control what this X distance is away from the machine home and what this Y distance is from the machine home. They're going to dial that into the table. Now, they've got about 5 different places, 5 different settings that they can make. To call up and understand that there's a work coordinate system, your program was saying G90, G20. We got to add a G code to our first initializing program. There are 4 different offset tables, or 5 rather. On the machine control. Set number 1 is what we call G54. Set number 2 is what we call G55. Set number 3 is what we call G56. Set number 4 is what we call G57. And set number 5 is what we call G58. So we're going to instruct as the programmers writing this program for this part, we're going to instruct the setup person to enter these offset values into our G54, or our first set, our first work coordinate offset values. And then all we need to do is add a G54 in our program right after the G20 is okay. Or if you've told them to load it into the G55 tool offset table, you would make that G55 in your part program. But you need to realize that we have to let the machine know that there are shifts that have happened from where my part actually is and where I have programmed it to where it thinks its 0 is. Some machines have it down here. It depends on machine. But the machines we have on the shop floor that we've demonstrated do it from the upper left-hand corner. So, and this allows you to have multiple setups on one table. So if we had another setup of some other part that looked a little different, like the one you programmed before, if that was a setup we had right here, and we said, okay, here is our origin, well, we can tell it this is the G55 work coordinate system, and we can have a whole different program that calls up G55 and then does all the movement that you just did when you proved out that program. So these are just different sets of offset that you can do. All you need to remember is that they need to be called out in our part program. So now we're at a point where I believe we should focus on making a more challenging real part. This is going to take you a little time to do, but I think it's something that will be of great value because it's going to use multiple tools, going to use multiple techniques that we talked about, cutter comp, drilling cycles, different tool offsets, different tool length offsets will need to be used. And the drawing that I want you to look at is in your manual. So you have all the information you need right here. Here's a list of your tools. Here it's saying to use the G54 in your program. Don't worry about what this is telling you right now, or what, here is the tool lengths and such, but don't worry about that. Just concentrate on this tool list and this geometry. This is a counterbore. Okay, and this material is 1 inch thick, so it's a plate, And what I'd like you to do is make a program that goes around, does the profiling, does the pocketing, does the counter boring, does drilling, and then here is a couple of 5 holes that require threads, chamfers. This is a real part that has many details. And come back to this when you're ready to look this over.